Right now we are going to be working on 5.3 problem 1, but we have had a question on last week's homework packet. On page 363 we're looking at number 14. Alright, Hector deposits into a simple interest account. The rate for the account is 5.25%. He's depositing 400. Here's the equation to represent the balance in the account. Determine the number of years it'll take for the account balance to reach each given amount. And, oh, maybe it would help if you could see, huh? Come on. There we go. All right, so you were already given the equation for Hector's interest. What they did right here is they took the 505 and replaced the P of T with 505 and then simplified. So we could do this problem like that. So Andy, you could do this problem by going 610 equals 400 plus 21t, and that you could do without a graphing calculator, just a regular calculator. But since we have a graphing calculator, what we end up doing is graphing that as its own function. One thing we know is that P of t equals, and we also know P of t equals 610. So we go ahead and do the intersect feature. Put both of those into y equals. One of them as a y1, the 610 as a y2. We go second calc, intersect. Uh-oh. Window, clear, window. Y max looks too small. Maybe if I make that 1000. So now, second calc, intersect. Oh, man. Let's see. Window, zoom, 0. It's still, I picked the one that doesn't work. I forgot my calculator at home. Let's see. Somebody else, I'm going to take one of those black ones. Yeah. We've had issues with that calculator, huh? Y equals, excuse me? No, I'm sure there's something that we need to, we could be smarter than a machine. Plus 21 t, 610 in the second function, second calc, 5 for intersect. I can't see them, but apparently it can. It's asking me for a first curve. I'll push yes. Second curve, I'll push yes. Guess, please. Okay, so y is 610 when x is 10. So the amount of money is $610 when t is 10 years. So if you're going to do this algebraically, you're taking this amount and setting it equal to the function. And then you would simplify and solve for t. If you're going to use a graphing calculator, you're going to put this in as y2 and use the intersect feature to find the years. Things like 17, double the original deposit. Well, the original deposit was 400, so doubling it means bring it on up to 800, and that's what you need to find the t for. Tripling the original deposit, if we start with 400, what's triple? 1,200. Again, if you're at home and you don't have a calculator, what the algebraic way to do this is whatever that amount is, set it equal to the function. The first thing that you do to solve this is you need to subtract 400 from both sides. You're trying to get t by itself. 1050 equals 21t. Then what do I need to do to get t by itself? Divide by 21. T equals, clear, mode clear, 1050 divided by 2150 years. Other questions on the packet? That came from Andy. He wasn't with us most of last week. Probably if you want to hold on to this, you can get more questions answered after school on Wednesday. I don't know how many other questions. Anybody else who was here last week? Oscar.
365.
Okay, let's see. 365. The bottom?
Yeah.
Okay. Mario deposits $1,000. The interest rate, it's compound interest. The rate is 5. The initial amount was 1,000. They already give you a function. Okay. Use graphing calculator to estimate the number of years it'll take for the counts balance. So we're going to do the intersect feature. And if you didn't have a graphing calculator to do this, why don't we do this? These two tables right here, I want you in charge of 32. If you haven't already done so, find an answer for 32. These two tables right here, you guys are going to be in charge of 33. If you didn't already do it, please find an answer for 33. Those two tables right there, you're going to be in charge of 34. Use the calculator. Here's the function you need to put in. Okay, and you're going to use the intersect feature. Y equals clear, 1,000. I'm going to put parentheses. 1.05, close the parentheses, raise it to a variable. And then you guys all start with a different y2. Where's the case for this one? Oh, there's two boxes over there.
Pencils.
Oh, pencil? I thought you said tissue. Okay, so these two tables. What do you get for 4,000? Second calc, intersect. Waiting for mine to think about it. Enter 3 times. Mode clear, window. Okay, so we need Y max at least to 4,000. And let's go in scales of 50. Now, second calc, intersect I did it the first time and my calculator couldn't give me an answer because I didn't have the window right. Oh, still. So, window, mode clear to get out of that window. I need X's that are bigger. I'll start at 0 and I'll go to 50. So far we've had nothing go bigger than 50. Let's see what happens. Second calc, so I'm running into issues, but I'm changing the window to maybe help the calculator figure things out. Oh, I can see a blinky cursor. Good, good, good. Enter 3 times. Yes! Y or T equals 28.4 years. Again, if you're coming up with error signals, go back to the window. Think about the situation. X is the years. What's the lowest number and highest number of years do you think you're going to need? And Y is the money. So I see this one goes all the way up to 10,000. The lowest amount of money is 1,000, his starting amount, and the highest amount is 10,000. Those are dimensions for your Y if you're trying to set the window to help the poor calculator out. Middle tables, what'd you get for 6,000? T equals 36.7 years. Okay, does that table agree? Okay. These two, 10,000. Were you able to find?
47.19.
47.19 years. Other questions on the packet? Make sure your name is on the top. Have one person from each table. Bring them on up, please. I think it's a little smaller. I tried to make it a little smaller. But I know you want to be as smart as me someday, so, you know. Okay, in your books, page 314. 314. How far have we gone on this one? 13 minutes because it's time to stop.